My name is Praveen Kolar. I'm a professor here in Bio and Ag Engineering, NC State University. I am here since 2008. I work on predominantly converting waste into different value-added products. The whole idea is to make every component of the ag supply chain economically viable. So for example, when we are growing chickens, in addition to chickens, we want the litter to be valuable as well to the producer. How? By making that into a high value compound. Now, some of the byproducts may not be directly economically viable, but they can be a precursor to something else for a different industry. So what we define as waste might be somebody's resource. So if you look at our projects, you will see that we take a waste and make something out of that and treat a different waste. So it's like a full circle. In my lab, it's a both combination of thought process and hands-on activities. We will first brainstorm and we have some working hypothesis. And when they go to the lab, when they try to actually implement that, sometimes things don't work out as we have planned, so they will repeat many times. And they see the concept and the reality as not always are the same. They have to explain why things are not working, and they think about that, the thought process comes into place there. Lot of hands-on activities, but we also supplement that with our thought experiments as well. Right now we're focusing on pine bark specifically. We have so much pine bark in the state and we want to add value to it. Nitesh is looking at pine bark. He's trying to add nitrogen to it on the surface to make it special, such that pine bark derived biochar can be used to treat aquacultural waste. And he's looking at the surface chemistry changes and how it can be enhanced so that it works as a magnet to selectively attract nitrate and then phosphate from the water. Rafsan is looking at poultry litter. It is a combination of wood chips and then manure. So he is looking at effect of temperature, effect of residence time, effect of activation chemicals, the surface chemistry, and then the physical properties of the biochar, which he will convert into electrodes and test its charge holding capacity. The byproducts from their research will be precursors for Victoria and Autumn's research projects. Autumn is taking those biochars and using them as catalysts to convert lignin into vanilla and cyrangaldehyde, because it requires the catalyst to be slightly alkaline. And it so happened that Nitesh, when he deposited potassium hydroxide, the catalyst became too alkaline, which is a perfect fit for her project. Victoria is looking at pine bark, and then her idea is somewhat unique. She is trying to extract the sugars first through the biochemical processes, through enzymatic processes. Once we extract the sugars, whatever is left, the spent material, will be the precursor for making a special type of biochar that can be used to remove an array of chemicals. So what she is doing is she is trying to pre-treat the pine bark and then hydrolyze it, remove the sugars, and whatever is left will be the feedstock for the biochar. And that biochar, after some chemical modifications, will be an outstanding material to treat air and water quality contaminants. What we do is based on what we think is appropriate from an environmental, ecological, and climate change perspective. And then all our projects, activities are in line with that. In a few years, we will have to use these bio-based products, because in 25 years from now we will have 2 more billion people on the planet, and we have to feed them, provide them with shelter, clothing, space, and other resources. So instead of relying on fossil fuels, we want to move towards something renewable. It's a great time to be an engineer. A lot of opportunities are there right now to move this field forward. And with the advent of machine learning and robotics, I think we will be doing great things in the next 5 or 10 years.